Let's consider performance of the juice bar. Well, let's try this one. Hopefully this is going to go. And we run it. I'm just going to stop it while we discuss this. So want to consider three cases with you here. The first is the base case. So we have two baristas working independently, essentially. So we're going to analyze just one of them, seeing arrivals at the rate of 65. They're providing service that has a mean of 40 seconds and a standard deviation of 20 seconds. I'm going to assume that it's a normally distributed service. There's just no need to analyze both because they're identical. No juice spots involved in this scenario. So you can see my parameterization here. Arrival rate is 65, mean service time of 40 seconds, 20 seconds standard deviation, one server, and we just run it to completion. Let's try this. We can speed it up, and I'm just going to run it to completion. So you can see that I think this is over 3,000 minutes. We've got barista utilization of 73%. There's no juice spots involved in the simulation, so that's a 0. So notice how this simulation is flexible. I'm able to analyze different scenarios by just appropriately parameterizing the analysis. So on average, we're seeing 1.79 about 1.8 minutes in the system. 40 seconds of which on average is, and that does vary, 40 seconds of which is in service itself, getting the actual beverage prepped. And then the remainder of that is going to be time in the line, which averages out to 1.11. So the difference here should be about 40 seconds. These are expressed in minutes, obviously. Notice that the mean service time is actually much lower than the average because it's right skewed here. And what else to note? I think that's it. So we're ready for our second scenario. And one thing to notice is that you'd probably want to run this multiple times, which we'll just do briefly here. I'll just run it to completion again. Every time you simulate it, you should get slightly different results. I see I did get the same ones here. I'm not sure quite why that is because I think it does use random seeds. But in any case, let's move on to the next scenario, which is going to involve a process innovation. Here we're looking to train the baristas. I'm just going to pause it. I'm going to need to make some changes. So we've had a few arrivals, just 2. So, ideally you'd want to have the parameters in place prior to the start, but that's going to get washed out. The small differences here will get washed out because it was just a few minutes of simulation time. So in the trained barista situation, the baristas are again independent, but now they've got training. It doesn't affect their mean service time, but it does reduce, we're assuming it reduces their service time variability from 20 down to 8. That's a 60% reduction. So only thing I need to change here is just crank this one down. I want it full screen so I can just eyeball that a little better. I want this to go down to 8. And my ability to get it to precisely 8 is dependent on the resolution of the slider. That's about as close as it's going to get. 803 should be good enough. And we'll run this to completion. So remember I had about 1.77 minutes in the base case. Training should bring some advantages because variance hurts. So reducing the variance should get us a better look on flow times. It's not going to change the utilization. It should still be 72, 73%. It did win about 0.1 of a minute. So about 6 seconds or so reduction. And now you're less than a minute in the line, plus another 40 seconds. That's your flow time. Right, so that was our first innovation scenario. For our second innovation scenario, we're going to pool the lines. Now, pooling is one of the big punches, big takeaways of this analysis. It usually has a dynamite effect relative to things like this, relative to what the training brought. So I'm gonna stop this and then just rerun it again and pause it. And we'll full screen it just so you can see. So what I want to do now is I want to lump the two lines together. So now the line is gonna see 130 per hour. Again, I think it's about as close as I'm gonna get, 130.12. For the purposes of, the sliders here, ideally should be, more refined. But that's good enough for our illustration. And then we're gonna go up to 2 baristas because now they're pooled. Okay, so you can see how the flexibility of this model works. Again, no 2 spots. Service time parameterization remains the same. Let's run this and I'm going to fast forward to the end again. And you notice how we went down from 177 to about 161 when we did the training. But here we're going 177 down to 113 on flow time. That's huge. Utilization remains the same. So now about 3/4 of the minute in the line plus your 40 seconds and you're at the door. So this is really powerful. Okay, so I'm going to end this clip, and then the next clip we will explore, a couple, 3 more scenarios. We're going to put the training and the pooling together to see if that's a win, and how much of a win it looks like, relative to the 113 that we just obtained. We'll also consider introducing the juice bot.